Hi everyone, this video is going to cover chapter 8.1. We are moving into a new chapter, which means I'm hoping that if you are watching this video that you've had an opportunity to finish the problem set and you're confident and moving into the next part of geometry. You will find that in chapter 8, you will need to review your previous knowledge of things like area, volume, surface area, so on and so forth. As opposed to making a video separately that talks all about that stuff and getting you to review it, I'm simply going to ask you to consider, again, if you have time, I suppose, page 414 in the textbook, spanning all the way to page 416, will get you to do a bit of a prerequisite to see if you're ready with basic areas and surface areas and whatnot. I also imagine that some of you have probably just memorized formulas up to now, not quite understanding. My goal and the way I'm going to deliver chapter 8.1 is to, in fact, get you to think and understand where all these formulas actually come from. It is the epitome, in my opinion, in grade 9, it is the epitome of logic. And so if you're able to wrap your head around this, I think you're, not only do I think you're sort of flexing your visual, spatial, muscles, you will also be able to, I think, reach a new level of logical, logical thinking and structure. So without further ado, 8.1 title is Apply the Pythagorean Theorem. Questions that I like you to do at a certain point is right here. Page 423 is where it starts, numbers 1 to 9. That's going to be your homework. Let's start with basics. We know that the Pythagorean theorem is a squared plus b squared equals c squared. That's something you've probably seen before, but if I were to break this down as a full review, a and b are two shorter side lengths of a 90-degree triangle. In other words, this could be A and that could be B, or vice versa. The base could be an A and the height could be a B. Next, the C, the letter that is on its own, in other words, the side length that is on its own squared on one part of the one side of the equal sign, is always going to be referred to the hypotenuse. Okay. Let's take a look at a basic question that I think you probably would have seen before in your in grade school. Here's one example. I'm just going to make it up, and please excuse potentially non-perfect drawings. We're going to pretend this is a 90-degree triangle. I have a side that is 8, I have a side that's 11, and I have the side that's x. Applying this, the question is, of course, solve. Find me the value of x. Knowing that this is Pythagorean theorem, or knowing that this is a right-angled triangle, you can directly apply Pythagorean theorem to this. The problem is, what side do you plug in? Some people, I imagine, in my, in my experience, whatever number that they get, they just automatically plug it into A and B. That is not correct. A and B are always reserved for the sides that are not the hypotenuse. Okay. Let's try to color coordinate this. 8 is a side length. Okay? And so I'm going to place that where a side length belongs. I'm going to pretend that is letter A. So this would be 8 squared. Next, using a different color, x is another shorter side length that is not the hypotenuse. So I'm going to place that where it belongs, which is b plus x squared equals. And lastly, I'll choose green. The hypotenuse, in other words, the side that is furthest from the 90-degree angle, arrow, furthest from the 90-degree angle is my hypotenuse. That is going to, oh shoot, ran out of pen room. That is going to be placed where that belongs. Right here, 11 squared. And the rest is going to be basic algebra. But please, you have to be careful of it. If you are not able to match this, and always remember that the hypotenuse belongs where the c squared is, you will not be able to progress further. So take this very, very, very seriously, and do not be confused if Pythagorean theorem is going to be mixed up in harder questions. Let's finish off this question before I continue. 8 squared is 64. X squared is unknown, and 11 squared is 121. If you want to solve for the x variable, you're going to have to isolate it, get it all alone. Well, how do I get it all alone? This positive 64 needs to go. I'm subtracting both sides by 64, bringing us to, let's see, 57. I'm not wrong, am I? I just did mental math, sorry. Yep, that's good. And so I have x squared equals 54. So what is x? How do I get rid of a square? In case you forgot, the opposite of addition is subtraction. The opposite of multiplication would be division. The opposite of a squaring would be the square root. You're going to square root both sides. This is going to be x, which is the square root of 57, which is plus or minus 7.5. 7.55, so I'm going to do 7.6 approximately. Why positive and negative? Well, again, as you might remember, if I have the square root of 4, the answer technically should be 2. Why? Because 2 times 2 gives me a 4. So the reverse would be true. But negative 2 times negative 2 is also a positive 4. So this could be a 2, or it could be a negative 2. You just don't know. Except here, we've got a context. What does the x refer to? The x refers to, let's see if I can choose the right color. The x refers to a side length. Does it make sense for a side length to be a negative? No. Therefore, negative 7.6 is rejected. The proper term for this is an extraneous extra root, an extraneous answer. Okay, an extra answer. Mathematically, a negative 7.6 is correct, but in our story, it doesn't make sense, so it is rejected. Therefore, the x is going to be approximately 7.6. That's the correct answer. Why am I reviewing something so quote-unquote basic with so much vigor? Okay, why am I making it such a big deal that you need to review this as best you can? Well, the answer is this. You are going to see Pythagorean, because it's so simple, you're going to see Pythagorean theorem sort of thrown around everywhere. Let me give you an example by doing one of the harder extend questions in this section. Please take a look at page 425, number 10. We are applying a Pythagorean theorem case to a 3D structure. Here we go. If you are not interested in watching me set up this question on the page, please, by all means, use the timestamp to jump to where you need to be. Okay, and then hey, that's not too bad for freehand. Okay, this is a rectangular prism. The base length is going to be 40 and 40, so that's a square. And the height is going to be 30. So the height being 30, of course, this side is also 30, this side is also a 30, the back side, the dotted line is also 30. The diagonal dotted line in the back is going to be 40 and 40, of course. Okay. The question is, what is the length of this? Oh, that's terrible. Let's do a green line. What is the length of this diagonal? It goes from the back corner of this rectangular prism to the front bottom corner. So something like this, we actually call that a space diagonal, a diagonal that cuts through the inner space of this rectangular prism. How would you go about doing that? Well, the key is Pythagorean theorem, but now you're thinking, whoa, 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 whoa. Pythagorean theorem is number one, I need a right angle triangle. Number two, I need a hypotenuse, so on and so forth. Well, what if I told you that there was a hypotenuse? There was a right angle triangle. Good. Some of you might not be able to see it right away. So I'm going to try to take this diagonal out and redraw it for you. This diagonal is actually the hypotenuse of a right angle triangle that's jutting out of the piece of out of your monitor right now. What do I mean by that? Well, you got to think about it in 3D. If you're not quite sure, maybe I could add some other things to this picture to help you reference. It's sort of like, have you seen those pictures where, you know, the further something is, the smaller it looks, and the closer it is, the bigger it is? It's sort of like that, okay? Imagine that's exactly what's happening. So this is your friend who's waving, okay? And you, who is the same height as your friend, is waving over here, saying, hey, can you see me? And here's another friend. Okay, you're all the same size, but because this person's closer, well, it looks bigger. Now, this is what I mean. This space diagonal, this right angle triangle is jutting out. The height here is still 30 because this height is 30. Okay. And so all I really need is this unknown sort of side for me to use Pythagorean theorem and find the hypotenuse. Well, how do I get that? Well, remember, this is the side I'm talking about. And that diagonal happens to be the diagonal of the base square, in fact. See if you can follow. Do you see this rectangle? Sorry, do you see this triangle that happens to be half of the floor of this rectangular prism, this cube, or so to speak? Okay. If I were to draw this out, this is what it is. I have another rectangle down here, and it just so happens that it is a 90-degree triangle. But it looks slanted because it's, of course, flat on the floor, right? This would be the floor of my box. So I'm going to take this triangle and I'm going to sort of lift it off the floor. Right? In case you're having a hard time understanding what I'm talking about. This side length is right here. And this side length is right there. And this blue dotted line is right there. Pause the video now and see if you can grasp what I'm trying to draw for you. Okay, I'm going to move on, assuming that you paused it to sort of digest it. What is the length of, or what is the height of this triangle? Well, that height triangle is actually this side length, which corresponds to this side length, which corresponds to 40. What is the height, or what is the length of this base? Well, it will be the length of this part of the triangle, which would be the length of that part of the triangle. This is 40. So in essence, this is 40 and 40. What is the hypotenuse? Pythagorean theorem, baby. 40 squared equals x. And this is what I mean by doing Pythagorean theorem on the fly. I didn't even wait to consider which part was a squared, which part was b squared, and which part was c squared. I knew the hypotenuse had to be alone. All the other parts just fit in together. So this would be 1600 plus 1600 equals x squared. Okay. So that's 3200 equaling x squared, which is square root of that, 56.57. I'm going to just round it to 56.7. So this goes all the way back. That means this portion right here, that is 56.7. Something happened to my cursor. 56.7. So let me redraw this. That's 30. That will be 30. That will be the base diagonal, and this would be the space diagonal. That would be 56.7, right angle triangle. What is my hypotenuse of this right angle triangle? 30 squared plus 56.7 squared equals x squared. 30 squared plus 56.7 squared, square root that. Do the work. X should equal approximately 64 units, whatever that unit might be. For this box, the space diagonal is 64, and you were able to calculate it by simply doing Pythagorean theorem twice. Just because you know the formula is not enough, please, would you try practicing, once again, numbers 1 to 9, and really get used to using Pythagorean theorem on the fly, rearranging it where necessary, like this example, okay, rearranging it wherever necessary, and being very comfortable using it whenever you want to. Not because a question told you, but because you think it might help. It should be quick, it should be clean, and it shouldn't cause you any stress. Just literally, it's just another tool in your toolbox. Once you're done that, we move on to 8.2. Please do not move on to 8.2 until you've tried the Pythagorean theorem, because I am going to take your knowledge of shapes for granted. Okay? Work hard, and we will see you in the next video.